Today I want to talk about DCC track occupancy detection. In simple terms, it is a way for the DCC system to see where a locomotive or a train is, which position the switches are in, and where the train can and cannot go, so that if you want to automate your system, or even if you just want the signal lights to switch, the computer can control that for you. I'm using the Roco 10819 here as the track detector module, and I also have a 10775 to operate the two switches on this small test track that I built to figure out what's behind this, because there's plenty of videos online about how you can use this system, how the computer runs it, and there's several videos about how you can program a train to go from point A to point B, and another train go from point C to D, and so that they don't intersect and crash into each other, fully automated, which is great. But I didn't see a video where it simply explains how this does and does not work. So that's the purpose of this video. So the way block detection works is relatively straightforward, actually. We have the P and the N that comes in from the Z21. I'm using the white one for this test purpose. And then the two rails that are closest to me on each layout, on each track here, this one and this one, is hooked up to the N, and then the P1, instead of going to the track, it goes to the module, and then each individual section is isolated from the rest of them, and when there's something on there, it'll detect the current draw on that section, and then infer that there's a locomotive on there, and it'll highlight it on the little schematic. So I made this rough schematic in the Z21 app, and I also have two switches in there. Again, this was just a simple layout that I did just for the sake of trying this out before I commit to it fully. So in this iPad I have my layout schematic, and in this iPad I'm using to control the trains. So both of them right now are between section 2 and 4. Actually, this one is partially on 3. Let's move it over here. So between 3 and 4, and between 11 and 12. So the first thing about this is that the detector doesn't go by those block numbers. I assume it has something to do with the 8-bit system that it operates on, but it does everything in multiples of 8. So number 1 through 8 is actually 1/8, and then starting with 9 it becomes 2/1 all the way through 2/8. So the mddm right now is between section number 3 and 4. So we're going to put it in motion. And there you can see that it is now in section number 3, right there. And we're going to move it up a little bit more. Now it is between section 2 and 3, and it doesn't detect. And now we're going to move it over section 2, and section 2 detects it, and we'll move it over to section 1. And now sections 1 and 2 detect it. So now we're going to move to class 118, which is currently between section 11 and 12, and we're going to put it in motion. And so it sees it on number 12. It goes into a neutral one, then it goes number 13, then again into a neutral one, and then it is on number 17. It goes across the switch. Switches are not detected, at least not from what everybody on YouTube says. And then it's going to end up at the end, just like that. So I have one locomotive there, and I have one locomotive there. So a couple things I discovered is that, first of all, a typical average piece of track, which is about 11 inches or so, is usually too short to house a full locomotive on it. Most locomotives are a little bit longer than that, and this detection system working depends fully on where the pickup is. So right now, the BR118 is sitting right there. If I move it over to this section right here, it doesn't detect it. And I assume that's because it picks up power from one track on from the left track on the front and the right track on the rear, or vice versa, whichever it is. But sitting right here, it does not detect it. So that means that you need to take into account the length of your locomotive, and it would be necessary to pretty much use at least two tracks together as one block to detect where it's sitting accurately. So the other thing that is noteworthy, especially for me, because I wanted to use this system to monitor my shadow station, is that the mddm is sitting right there, but it doesn't see it. And the reason for that is because the lights are out. If I turn the lights on, it will detect it. So that means that I would have to have all the locomotives with their lights on while they're parked there at the shadow station, or the computer would not see them. So the other thing noteworthy is your rolling stock. The track detection absolutely does not see any of your carriages or wagons. They don't draw any current, therefore they're non-existent to it, which again is a concern when you're trying to do this in a shadow station that's out of sight, and you have to leave your locomotive lights on. And after doing some research, I found out that apparently the solution for your carriages is that you would have to put a resistor on at least the front and rear axle of a train composition, or the front and rear axle of every one of your carriages and wagons. So while the DCC sees the locomotive standing there, as soon as the locomotive leaves that track, the carriages are of no concern and it doesn't detect them. I did a little bit of experimenting with the resistor value, and I found out that approximately a 3 ohm resistor will register if I just put it across the track. So putting a resistor in every one of my carriages and freight cars is possible. I think it's a less than ideal situation. Another option is you can put in the Roco app, for the Z21 app, you can put in length of your train composition, and that may be something that is worthwhile. But again, it's pretty, I'm not as impressed with it as I thought I would be. I thought it's going to be a great solution, but first of all, the length of the locomotives. So for instance, this here is a standard piece of Piko track, and it's about the right length. I severed it right here to make I had to isolate it from each other. But again, it's not the solution I thought it's going to be, and I'm not sure if I'm going to proceed using this as my detection system. There are other systems out there, primarily using infrared light, and it senses whether or not that light's been interrupted or not. It too has its drawbacks. I'm not sure if it's compatible with the Z21 system. They are mounted pretty much in between the track, one shining up, the other one, well, both of them looking up, and then they invisibly kind of intersect, and then when the train passes over it, interrupts that beam. So let's take one more look at this system in operation. So right now the train's sitting right there. I'm going to change the 2 switches and up the throttle, and so it has left that last section. It sees it on the one prior to the switch. It does not detect the wagons, but it detects the locomotive between the switches. It leaves the switch, and then it goes after that, and it is on the final section where I'll stop it. And so it sees the locomotive right there, but it does not see the freight cars on sections 1 and 2. So to set up the 10819 is relatively simple. Again, in the Z21 app, you'll go to Control Station, and then this is the little diagram that I made. And so let's take this one right here, which is the one at the very end. If you edit it, you simply put in the number, and since this is more than the first 8, it becomes number 2, and then the input becomes 8 because technically it's number 16. You can choose which one you're using. I'm not sure what to do if you don't have one of the ones that's listed here. And also the afterglow is a value where you can put in how long it will show it as being occupied after the locomotive has left that track, so that if you have sections close together, they don't flicker off and on, they'll stay on steady depending on your needs. So let's do one more test with this ESU lock. It has sound and a lot of functionality built into it. Let's see what how it is perceived by the system. So we're going to start with the lights off and everything, and we're just going to crawl forward here. Right now it is sitting on an undetected section. The next one it can be detected at is number 4, which is that one right there. So let's see. Yes, it sees, well, it flickers, it sees it, then it goes over the switch, and then the connecting piece, it sees it there, and then the next one here is 15 or 2-7, it sees it there. And then it's going to go all the way to the end, the 2-8 or number 16. And it sees it, will stop. So it's sitting at number 16 or 2/8. We'll reverse direction, flip the switch, and we'll send it back our way. 2/7, it sees it, it goes over the switch, 2-6, it sees it, and then number 13 or 2-7, or 2-5 rather, it sees it, and then it comes to rest on the neutral one. So all in all, I'm undecided about this. It works okay. I think I can deal with having to leave the lights on a train in my shadow station, but I'm not so sure that it's going to do the job if I have to, if it won't detect all the passenger cars and the freight cars unless they have resistors soldered onto the axles. And there's a couple of videos on how to do it, and I mean it's definitely feasible, it's definitely possible to do, but it's just not the solution that I was hoping it's going to be. I may incorporate it in a limited amount just on that shadow station, and maybe with some small microcams where I just have a view of that. I think it's 4 tracks or 5 tracks in that area. So I may just do a combination of the two, or one or the other, but overall I don't think I'm going to proceed with automating my track and relying on this, even though it's a very cool idea. It's just not going to be for me. I hope you got some use out of this. Thank you all for watching, and until next time, bye bye.